Just as 2 points defines a line, 3 points define a plane. We have 3 points here, and we'd like to find the equation of the plane containing these 3 points. In order to find an equation of a plane in general, we need a normal vector and a point. So we need a normal vector and we need a point. Well, we got 3 points, so that's good news. We can use any one of those 3, but we do need a normal vector. For the normal vector, to get the normal vector, what we're going to do is we're going to create vectors in our plane. So the vector PQ, for example, is the vector connecting the point P to the point Q, and we know that that's 3 minus 1, comma 0 minus 2, comma 4 minus 1. Another vector in this plane is the vector QR. We obtain it in a similar way. Negative 2 minus 3 is negative 5, 2 minus 0 is 2, and 1 minus 4 is negative 3. So I now have 2 vectors that live in the plane that I'm interested in, right? These points live in that plane, so the lines connecting these points are also in that plane. So these 2 vectors are in the plane of interest. To get something perpendicular or normal to the plane, I take the cross product of these 2 vectors. So the cross product, PQ cross QR, is the cross product IJK 2 minus 2, 3, minus 5, 2, minus 3, and that gives me the vector 0, minus 9, minus 6. We've already seen how to do this, so I'm not going through the details on that. But we get that as the cross product of these 2 vectors. Remember, the cross product of 2 vectors is orthogonal to each of those 2 vectors. So the vector we have here is orthogonal or normal or perpendicular to PQ and QR. These both live in the plane, which means 0 minus 9 minus 6 is normal to the plane. It's orthogonal or perpendicular to the plane. We now have our normal vector and we have our point, so we can find the equation of the plane. And the equation of the plane is going to be 0 times x minus 1 minus 9 times y minus 2 minus 6 times z minus 1 equals 0. This is negative 9y plus 18 minus 6z plus 6 equals 0. So that is negative 9y minus 6z equals negative 24. And I might as well divide that through by negative 3 to get 3y plus 2z equals 8. And that is the equation of the plane containing these 3 points.